Hello and welcome back. In this video we'll take a slightly different approach how we can use TensorFlow. TensorFlow is of course one of the big libraries in machine learning and deep learning, but we can also use some parts of it in a different way, because it turns out a lot of the methods that we use for machine learning and deep learning are based on mathematical operations, in particular matrix operations. So we can use these libraries also if we have other problems and tasks that we want to do that involve similar type of calculations, and that gives us, in a sense, for free access to how to implement and solve these kind of issues effectively also on clusters and graphics cards. And as a very simple example, we want to look at linear regression, how we can use that in TensorFlow. So let's start by creating some example data. So we just create 2000 data points along a straight line, and to make this a bit more complex, we add some noise to this. You can see that here, indeed, we do have a straight line, and this is scattered about because we've added some noise to the data. So the y values are the true slope with the x data and some offset and some noise. Now, example here, we've used the offset of 0, right? But we could make this a bit more general. So the linear regression is then indeed that we fit a straight line to these data points and take the line that sort of fits best to that. So here, the variable y is given by this formula. X is the independent variable, right? So this is where the data comes in, and then we need to tune m and b. And because we've defined our slope up here to be 1 and the offset of 0, so ideally we want to recover that m is 1 and b is 0. In order to do this with TensorFlow, we need to initialize this as variables. And so we take it with a predefined value based on the normal distribution, what we could also just put it to 0, for example. And we need to give it an optimizer, because we will still use the same way of training a machine learning model, so we use the same sort of mechanics. We also need to define a loss function, because this is a regression problem, and we have a line that we want to fit the points with. We use the mean squared error as our loss function, and the prediction is based on the line, and these are the true data points. And then we can use the same sort of approach that we use in TensorFlow. We can iterate for a number of iterations and then use the gradient tape method, which gives us a more granular access on how to work with TensorFlow. And so here the key point is that we have our straight line, our linear regression, and remember that we defined m and b now as variables in TensorFlow, and x is the data, right? So we have m and b as variables and the data that we want to fit, and here is our prediction. So the loss function is the mean squared error, and this is just a fancy way of writing the sum over the squares. And here we have the prediction, this is what we have, and this is the data that we have generated above. And our gradient descent is then based on this loss function plus the two variables that we have. So the optimizer needs to move those two variables such that we find the best way. And if we do this, you can see that within a few iterations we do indeed converge, and this is the loss function. Now we can plot the true line and the line that we have fit from this data, and you can see that these match fairly well.